All right, now we're on example 4, finding the domains of piecewise defined functions. Here we're looking at a piecewise defined function with 3 pieces. Oh no, whatever shall we do? 3 pieces. You do the exact same thing you did with 2, except now you just have 3 intervals to consider. Nothing unusual here, it's just a little bit more involved. All right, so how do we start this? Shade and erase method as before. So we start with this guy here, this criteria. X is greater than or equal to 0. Because of the equal sign, we're going to put a square bracket at 0. And then since x can be greater than or equal to it, I shade to the right. Okay, so that handles that. Boom. All right, now let's handle the next part. From x is equal to, from -3 to 0. X can live between -3 and 0, but not -3 and not 0. So it stops at 0. We'll put a round bracket at 0 on this side. And it goes to -3, not including -3. So I'll put a round bracket there. X can live between either one of these guys. So sometimes it's better just to supersize your brackets and then shade a little bit in between them. Okay, so there's that interval. Boom. Now, x is less than or equal to -3. So I'm going to put a square bracket at -3 and then shade less than it. So it looks like, since the round bracket here meets up with a square bracket, I'm looking at, well, -3 is included. Similarly with 0, I can plug in 0 so far because of a square bracket and a round bracket. So it looks like this thing should theoretically be defined everywhere. Now let's see if any of our pieces here have breakage in them, i.e. division by 0 or square roots of negative numbers. So looking at the first piece here, we need to figure out what to erase. So we have square root of x plus 1. When is the inside of this going to be negative? That is when x plus 1 is less than 0. Okay? But that implies, if and only if rather, x is less than -1. All I did was subtract 1 from both sides. Okay, so whenever x is less than -1, I'm going to have a square root of a negative number. So I want to erase everything less than -1. But I also have to be careful because here, this function is only defined up past 0. So x is less than -1 are the only things that's going to cause problems. However, this function is only defined when we're talking about x greater than 0. So none of these x values are going to cause a problem. So this will never be, on this interval, a square root of a negative number. Okay? So we're stuck with this interval. This is solid. We'll just fill it in even deeper if you want. All right? So we're not going to ever have a square root of a negative number when x is greater than or equal to 0 because all of our square roots of negatives happen when x is less than -1. So we're safe. Now let's consider this guy. So when can I possibly have division by 0? So it's when the denominator is equal to 0. Either x is going to be 2. If I plug in 2, then I have 2 minus 2, that's 0, and this whole thing goes to 0. So I have 1 over 0 when x is 2. Is 2 going to be inside this interval, or inside here? The answer is no. 2's over here as it pertains to this guy. Has nothing to do with this interval. So 2 is not going to cause any problems. How about 3? Excuse me. How about at 3? As you notice, 3 lives over in this interval that we shaded before. So 3 is not going to cause any problems. 2 and 3 both live in a different interval than the one that's meant for this guy. So we're stuck. This is solid. There's no holes, no nothing in there. All right, so now we're done with that. Let's handle this third case here. When are we going to get a square root of a negative number? Well, that's going to be when x plus 6 is less than 0. Okay, but that happens if and only if x is less than minus 6. All I did was subtract 6 from both sides of this inequality here. Okay, so that means whenever x is less than minus 6, I'm going to have square roots of negative numbers. So from here down is a problem. So I'm going to put a square bracket here and erase everything. Oops, I started at minus 7. My bad. Let's do this at minus 6 because x is less than 6. And then we erase everything less than minus 6. All right, so this is solid then. The reason we have a square bracket there is because everything strictly less than minus 6 causes a problem. Anything greater than or equal to, I'll write this, everything greater than or equal to minus 6 is okay. And this is what causes problems. Okay, so we erase the thing that causes problems, we leave everything else that's okay. So we are left with this nice shaded region here that starts at 6 and doesn't stop anywhere because the square bracket and the round bracket line up, the round bracket and the square bracket line up, so we're okay from minus 6 onward. The domain of f, in this case, is minus 6 included to infinity. And that's our domain. All that work for this little domain. Sorry, but sometimes that's how it goes. All right, in the next example, we'll do another, we'll basically work a similar example to this one, and hopefully we'll be able to erase a little bit more than this particular example. See you there.